Okay, so for this question, it gives us that these graphs show different linear functions a, b, c, and d, which each can be written in the form y equals mx plus b. Identify which of the four graphs has the indicated properties, and we need to explain our reasoning for each. So a, m is greater than 0, and b is less than 0. So both of these have to be true. So m is our slope. So positive slope means that it's increasing as we go to the right. So b is going up as we go to the right. So is c. A is not. A is going down, and D is also going down. So it means it cannot be A, it cannot be D, because both of those have negative slopes. Now for our B being less than 0, that means our y-intercept is less than 0. That means it has to start on the bottom half, right? Line B starts up here, that's on the top half, so it can't be B. C starts down here, that's the bottom half, so that means it must be true. Y, slope is positive. And the intercept is negative. Okay. Now going on to part B. Now it's saying that the slope is now less than 0, and our y-intercept is greater than 0. So slope is less than 0. That means it has to be decreasing. Well, from before we know that A has a negative slope, and so does D. So it means it has to be one of those two. So we can rule out B and C. And now it says our y-intercept or B is bigger than 0. So y-intercept bigger than 0 means it has to be on the top, start up here, which is A. Because D starts below, so it means it has to be A. Y, slope is negative. And the intercept is positive. Now for this one, both the slope and the intercept are less than 0. So we said before, slope that are negative are A and D, so that means it's not B or C. But now our intercept would be less than 0, so it has to be down here, which that is going to be D. Why? Because the slope is negative. And the intercept is negative. For this next question, it says the cost of X yearbooks is D dollars, where D is a function of X. The average rate of change is constant. It's $15 per yearbook. If the cost of N yearbooks is $2,000, what is the cost of N plus 1 yearbooks? So this question, just like visually looking, it's kind of tricky. We have this N and this N plus 1. But the big thing is this thing that I circled is just that the average rate of change is $15 per yearbook. So that means for every time we make another yearbook, the cost, which is D in dollars, is going to go up by 15, right? So we have N yearbooks costing $2,000. We're increasing it by 1. Increasing it by 1, as we just said, increases the total price by 15. That's what this is, constant rate of change. Average rate of change being constant is saying. So that means that N plus 1 yearbooks will be $2,000 plus 15 more for the extra yearbook, because that was N. It's $2,000 for N yearbook, so N plus 1 is going to be $15 more, because there's just one more yearbook. So it's going to be $2,015. Okay, so for this next one, we are told that fx is an exponential function such that f of negative 1 is 6.4 and f of 2 is 12.5. Find a formula for f of x. Well, first I'm going to write down what the general formula for this is, which is going to be f of x. F of x is going to equal a times b to the x. And I can also use our initial information. So I know if I plug in negative 1 in for my x, I get out 6.4. So it means that 6.4 equals a times b to the negative 1. And that if I plug in 2 in for x, I get out 12.5. So 12.5 equals a times b squared. Okay. So what I'm going to do is, so I will go ahead and I will take this first one and I will divide it by the second equation. So 12.5 over that, a times b squared over a times b to the negative 1. Those a's cancel. When you have two things with the same base divided by each other, you can just subtract the exponent. So it's going to be b to the 2 minus negative 1. 2 minus minus 1 is going to become 2 plus 1, which will be b to the third. So we get 12.5 over 6.4 equals b to the third. And then we can take the third root of both sides. So the third root of 12.5 over 6.4. And you can go ahead and calculate this in your calculator. Third root of the whole thing. Just be careful with like rounding because you might get something that's a little bit off because it's going to be a very exact answer. So we get, for b, plug that into your calculator, you should get 1.25. And if you round it, you might get something a little bit different. So it's good generally not to round. So we have that. Now we know what b is. The question is, how do we find a? Well, we know that f of x is a times, now we know what our b is, 1.25 to the x. We can use one of these points that we know and plug that in. So 12.5 equals a times 1.25 squared. And that gives us 12.5 equals a times 1.25 squared is 1.5625. Divide each side by 1.5625. We get a equals 8. So finally, our equation for f of x is 8 times 1.25 to the x. So for number 14, we have a sample of rock was found to contain a mixture of minerals, part of which were radioactive and decreasing over time due to radioactive decay. The mass M of the rock in grams after t years is given by M of t equals 15 plus 3.8 times 0.785 to the power of t. What was the initial mass of the rock? So the initial, fancy way of saying is no time has passed. So when no time has passed, it means that our time is 0. So we plug in 0 in for that. So M of 0 is 15 plus 3.8 times 0.785 to the power of 0. Anything to the power of 0 is 1. So that's 15 plus 3.8 times 1, which is just 3.8. Which that means we get 18.8. And we include our units. Our units is, our mass is grams, so that's going to be 18.8 grams. Now the next part is, what should the mass of the rock eventually become as time approaches infinity? So this one be a little bit more conceptual. I'll write the equation one more time. For 8.785 to the t. So we're saying as time goes to infinity. Okay, this gets bigger and bigger and bigger, right? Well, 0.785, that's a decreasing to the t, that's a decreasing function, right? As time goes on, our stuff is decreasing. So one way you can view this 0.785 is that each year you have 78% left what you had before. So for example, if you have $100, the next year you'd have $78.5 because you only have 78% of what you had before. So every year you will lose like 21.5%. So this, as t goes to infinity, this thing gets smaller and smaller and smaller. And eventually that's going to go to 0. So 15 plus 3.8 times something that's getting closer and closer to 0 is going to get closer and closer to just 15. Because this part is going to disappear. So to include units, we'll get 15 grams as time goes to infinity. To draw out what this looks like, this is 15. We start out at 18.8. And as time goes on, it's constantly decreasing and decreasing and decreasing until it gets closer and closer to 15, but it'll never cross over that. Okay, so for this next one, we have assume the equations for a, b, and c and d can all be written in form y equals a times b to the t. Which of the functions has the largest a value? Well, our a value corresponds to our initial amount or our y-intercept. So which of these has the highest y-intercept? And it looks like it's going to be b. So b, I'll just say greatest y-intercept. Okay, which of these have the same a value? So it means which two cross the y-axis at the same time? Well, looking down, this one doesn't have cross at any other time. Right here, two of them are both crossing. So I'm going to say it's going to be A and C. My expressions both cross y-axis together. Just the idea is I just want to try to say that they intersect on the y-axis. Like they're both at the same spot. Which of these functions has a b value between 0 and 1? So our b value is going to be based off of our rate. If b is greater than 1, it's growing. If b is less than 1, but bigger than 0, it's shrinking. So basically it's saying which of these is shrinking? Well, a is shrinking. And let me look, that purple, b. Our explanation is because you say they are shrinking. I'll say they are decaying. I think that's more accurate. Decaying. And which one has a b value greater than 1? This is going to be which ones are growing. Well, that's going to be C and D because they are growing. So this one says assume f is an exponential function. Fx equals a times b to the x plus k, where b is greater than 1 and a is negative. That's really big. They even underline it for us. And k is a real number. So is the graph increasing or decreasing, concave up or concave down? So first let's kind of get an idea of what this graph looks like. So a is negative, right? So previously we said, oh, well, when b is bigger than 1, it's growing. Well, because it's negative, that's going to flip this over the y-axis, right? So this is for a is positive, which is bigger than 0, and b is bigger than 0. It will look something like that. But because a is negative, that's going to flip us over. So instead, it's going to look more like that. Where I'll put the line in red. How about that? Where it's similar as, going to shoot up, but now it's going to shoot down. It's going to start below. So I'll erase this thing because we don't need that. That's just for illustration. So getting an idea of the graph. Well, so this part would shoot down like that, but this plus k is going to be like a shift up, right? So that means that instead of our asymptote at 0, we're going to shift it up to wherever k is. So I'll say that this value is k, ... It looks something like that. So is this decreasing or increasing? It's going to be decreasing. Is it concave up or down? Well, it's decreasing, and it's more and more so. It kind of almost looks like, if I were to extend this, it looks almost like an N for down. So I'll say that's concave down. Okay, what are its domain and ranges? Well, our domain is going to be all the x values, because any value of x I can plug in is going to keep going on forever that way, and it'll keep going on forever this way. where it might be something really big if we want to look at for a big x value, but it's going to be something. So domain, I'll just put D is minus infinity, comma, positive infinity. It was the range. Well, this is going to keep going down forever, so we don't have the lowest value, so we'll start at negative infinity. But it's only going to go up until it hits k. So it's going to be to k. Okay. Next question is, as x approaches negative infinity, as we go to the left, what does f of x approach? And that's going to be approaching our asymptote, which is k. And then for the second part, as it goes to positive infinity, what does it approach? Well, as we go to the right, we're going to just keep going down and down and down. So we'll say that approaches negative infinity. So for number 17, we need to write a formula for each of these following situations. So for the first one, part A, median home prices in the U.S. were about $186,000 at the end of 2008. Fell about 2.5% per year for a few years. Let M be the median home price and T be the number of years since 2008. Well, this is going to be an exponential formula because it's falling by a percentage each year. So our formula is be y equals a times b to the t, where a is our initial amount, and b is equal to 1 plus r, or b is 1 minus r, depending if r is increasing or decreasing. So for this one, our initial amount is going to be, it wants it in terms of m and t, so I'll say instead of y, I'll use m. It's going to be our initial amount, which is 186,000, times our b, which is 1 minus our rate, because we're falling about 2.5%, so 1 minus 0.025, it's going to be 0.975, so 0.975 to the t. For this next one is Dan had an annual salary of $30,000 when he was hired, and has had an annual salary increase of 3.2% each year. Let D be Dan's annual salary and T be the number of years. So again, this is going to be an exponential. So it's going to be D is going to equal our initial amount, which is 30,000, times, and then for our B, we're increasing by 3.2%, so that's 1 plus 0.032. So it's going to be 1.032 for B. So it's going to be 1.032 to the T. Now, for this last one. The population of India was about 1.22 billion people in 2013. It was growing at a rate of about 1.28% per year. Write a formula for the population P of India in billions as a function of T years since 2013. So again, it's going to be P equals our initial amount, which is 1.22, because it says in billion, so 1.22 billion is our initial amount, times, and now for our B value, it's growing at a rate of 1.28% each year. So it'd be 1 plus, and we got to convert that to a decimal, so 0.0128, so 1.0128. So I'll put that in there, to the T. And there we are. Now for part B, so the equation we had was P equals 1.22 times 1.0128 to the T. That's just from part A. If the growth rate stays constant, predict the population in the year 2050. Now, one thing it said previously about our T, I said 2050, I meant 2020. This is years since 2013. So for this one, in the year 2020, how many years since 2013 is that? That is going to be 7 years. So we'll plug 7 into that. So we'll say 1.22 times 1.0128 to the 7th. Well, first I'll do 1.0128 to the 7th, which I got was going to be 1 1.0931. And multiplying those together, I get about 1.33 billion people. So I'll put billion. Okay. By what percentage did the population of India increase in that 2-year period between 2013? Sorry, in the 2-year period between 2013 and 2015. So, in order to figure out how much it increased, we can do it a couple different ways. But the way I'm going to kind of set it up is I'll say population in 2015 over the population of 2013, which our t is going to be measured in years since 2013, so this is p of 2 over p 0. So plugging each of these in, it's 1.22 times 1.0128 squared over 1.22 times 1.0128 to the 0. Well, these cancel, and anything to the 0 power is 1. So that's the same thing as 1.0128 squared, which is equal to 1.0257 just to keep around, just to round it. So what this is I guess the proportionally how much larger is it compared from before. So to find the amount it increase is how far over 1 is this, right? So this is like your b value over those two for each set of 2 years. Every 2 years, your b value is 1.02576. So to find the amount you increase, you subtract 1, which is 0.02576, which is the same thing as I'll go and round it to 2 decimal places, 58%. So we've increased by 2.58%. You multiply that times 100, you get 2.5676, which when you round, sorry, I'll write this clearer, which when you round is 2.58%. So you set up the proportion between the population. You find that the population in 2015 is 1.02576 times larger than 2013. So to find the percent that you've grown, you subtract off the 1, and you multiply it times 100, and that gives you your growth in a percentage. Okay, so now for this next one, we have a 5-year certificate of deposit, which they call it, it's like a CD, I guess. It's opened with a $6,000 initial deposit at an annual percentage rate of 2.9% compounded monthly. So for it being compounded monthly, our equation is going to be A equals our principal, aka our starting amount, times 1 plus the rate over the number of times we compound in a year to the power of n, which is the number of times we compound in a year again, times t. So in this case, our equation is going to be 6,000, 1 plus, and then our rate is 0.029. We compound it 12 times a month to the 12t. And to figure out what it will be at the end of 5 years, we're going to plug in 5 for t. So we get 6,000, 1 plus 0.029 over 12 to the 12 times 5, which you should get about 6,000. And then that exponent thing, what I got was 1.1554. And then multiply that times 6,000. I got $6,935.02. Okay. What is the percent the account's going to grow in 1 year? Round the percentage to 2 decimals. So I'm going to kind of set this up the same way. I'll say the amount after 1 year over the amount at the start. So we need to see how much we grow in a year. Well, that's going to be, on top, it'll be 6,000, 1 plus 0.029 over 12, to the 12 times 1, which is just 12, over 6,000, 1 plus 0.029 over 12 to the 0. Anything to the 0 power is 1. So these 6,000s cancel out. We get left with just a 1 on the bottom. So we'll get 1 plus 0.029 over 12 to the 12th, which I got was about 1.0294. So we subtract the 1 to get it into the percent that we've grown, because this is, the next year is 1.0294 times bigger than the previous year. So to find the percent you grow, you subtract the 1, you get 0.0294. Multiply that times 100 to get it as a percentage, 2.94%. And there's that one. For this next one, an investment decreases in value by 5.3% each year for 3 years. By what percentage does the investment decrease over the 3-year period? Round your percentage to 2 decimal places. So first, our equation is going to be something like y equals ab to the t, where a is our initial amount, which we don't know, and b is going to be 1 plus r if we're growing, or 1 minus r if we're shrinking. So in this case, b is going to be 1 minus 0.053 because we're decreasing. So b is 0.947. Okay. So to see the amount that or the percentage we've decreased over the 3 years, I'll kind of say, instead of y, I'll call this p of t, just to make this seem a little bit, more official. I'll take p of 3, and I'll divide p of 0. So p of 3 is going to be a times, because we still don't know what a is, 0.947 to the 3, over a times 0.947 to the 0. A divided by a, those cancel. 0.947 to 0 is 1, so that's 0.947 to the 3, which is 0.8493. So one way we can view this is that this is our b value. So 0.8493 is going to be, we're decreasing, so I'll say 1 minus r. I'll add r, I'll subtract the 1 over, so get negative 0.1507 equals negative r. So 0.1507 is r. So how much did we decrease by? Well, we decreased by 15.07% over those 3 years.
Now for our next problem, we're looking at this function here, this function right here, and what we want to know is that if t increases by 1 unit, then what percent should f decrease by? So similar to last time, I'm going to write down p equals a times b to the t. We can also think about this as a times 1 plus our rate to the t, where 1 plus the rate, that's just equal to b. Now here, we have 1 plus r equals 0.649. And if we want to find r, which is just the percent, we'd say r is equal to 0.649 minus 1, which would give r equals negative 0.351, or decrease by 35.1%. For number 22, we're given a continuous growth rate function where we have, 80 times e to the negative 0.4t, where t is the time in years, the continuous growth rate is blank. So for these, our equation is going to look like P equals A times ERT, where A is just the initial value, and then R is the growth rate, and T is time. So here, what we have, we know that R is what we're looking for. What you see there is that it's a value of 0. Equals negative 0.4. And we know that they said it's already decaying, so negative 0.4 as a percent, we're going to be decreasing by 40%. Now for this next one, we have if f of t is this, the same function, t is the time in years, there's a decrease of blank percent each year. So now what we're looking at is, I guess we want to convert this continuous growth rate function to a compounded one. So kind of like what we were doing earlier. And the way that we want to go ahead and do that is just set up, using this as our formula, and say, okay, well, normally we have 80 times e to the negative 0.4 t. That is going to be equal to a times b to the t. Now again, we know our starting point is 80, so we're going to have 80 times e to the negative 0.4 t is equal to 80 times b to the t, which means that the 80s will go away. And we're left with e to the negative 0.4 t is equal to b to the t. And what we want to solve for is b. So there's a couple ways we can go ahead and do that. I'm going to say that I'm going to express this left-hand side as e to the negative 0.4 raised to the t is equal to b to the t. And then from there, we can say, okay, they have the same exponent, so they must be the same. Then b is equal to e to the negative 0.4. Now calculating that gives a value of b is about equal to 0.6703, which is, again, the same, remember, as 1 plus the rate. So think about our rate. The rate on a percentage basis is 0.6703 minus 1, which gives us that the rate is equal to negative 0.330, or 33% decrease. So again, there's a decrease of 33% each year. Moving on to the next problem, we have true or false. If a population increases by 10% in 1 year, it will increase by 20% in 2 years. So I guess the way that I would kind of think about this is 10% increase corresponds to an exponential function where the thing that's being thing to the exponent is 1.1, or b. So if you were to set up p equals a times b to the t, if we think about our first term is p of 0 is a, we want p of 1 to be 1.1a, which is just an increase of 10%. So then p of 2, to determine that, we'd say, okay, well, that's a times 1.1 squared, and that would just give us 1.21a. So here we can see, okay, this is a 10%. Now if you go 2 years though, we end up going 21% over. So therefore, for this question, I'm going to have to say that that is false, because we're not growing by 20%, we're growing by this 21%.